Stefan reduction. Let us learn Stefan reduction. Here this S and here this N. One first last. These both will come here as Sn, and here this R and this N will come here R and N. Okay. So here Stefan Sn Sn Rn Rn, right? So here we will add C, and here also we will add C, but here only C, here we will add the Cl2. So Stefan reaction can be easily understand only by the name of the that Stefan reduction only. So here Sn Rn, where Stefan reduction, so RCN plus SnCl2 give rise to, this will be intermediate. If you are okay with this, you can write, or else you can directly write this as an aldehyde. Okay, here also there is not much. Okay, here this RCN will be there, only 2 hydrogen will be added. Okay, here Cl2 will be there, same like only 2 hydrogen will be added, and again there will be H3O, which will be a protonation will take place, and there will be removal of this NH3 will NH will take place, and addition of oxygen will take place. That's all. This is the simple Stefan reduction. Then we will go for Gattermann-Koch reaction. Okay, here there is a CO, right? Here there is a CO and there is an AN, right? Here in the last there is a and here there is a CO. Okay, when benzene ring as an reagent, right, this CO will come here as an carbon monoxide as CO, right? And then there is an anadded AlCl3, which can be denoted here Gattermann. Last there is a MAN, right? This AN can easily put into here, right? So there will be AN, so this indicate there is an anhydride AlCl3 will be added. So in the last there will be aldehyde, right? Okay, then there will be Wolff-Kishner reduction, right? So here there will be two scientists, one will be Wolff, another one will be Kishner, right? So here in the Kishner we can find there is an inorganic reagent, where we can find here C, ER not there, IK, KI not there, SH not there, so NH, right? So easily we can, our eyes will go through here called NH. So here there will be two scientists called Wolff-Kishner, so we will take twice NH called NH2 NH2, right? So in the Wolff-Kishner there will be two steps will be take place. First will be addition of hydrogen and second will be the KOH, right? So the removal of N2 gas by the take place by the KOH, right? So first of all we will take ketone, right? Then there will be removal of water will be take place from this hydrogen, and addition of this take place, right? By the removal of just the water we can easily add here, and then by the KOH we can get the hydrocarbon, right? So it is one of the most simple. So easily by this trick you can easily find out the products and the reagents, right? So welcome to chemical enlightenment, right? So here we can, I will discuss some of the tricks and the easily getting points for your second PUC organic reactions, right? So here all chapters like haloalkanes, haloarenes, alcohols, phenols, okay, ether, and also by the aldehydes, ketone, carboxylic acid, all reactions can be discussed here, and the tricks which can easily you can write in the examination. Okay, let's start the first lesson, that is haloalkanes and haloarenes. Okay, in the haloalkanes and haloarenes, haloalkane and haloarenes, right? So the first reaction will be, first of all I want to conclude that any you can take any chapter, you can take haloalkanes, haloarenes, alcohols, phenols, ethers, or aldehyde, ketones, carboxylic acids. Okay, any reaction, any chapter, there will be divided into two parts. Okay, first of all I have to tell this. Okay, you can take any, you can take any chapter, it will be divided into two. First will be preparation and second one will be reaction. Please understand this. Okay, in the preparation it will be preparation of halogens, right? Means preparation of haloalkanes. Okay, and here the reaction with the haloalkanes, same like preparation of alcohols, preparation of ethers, right? Preparation of phenols, preparation of aldehydes, preparation of carboxylic acids, and preparation of ketones. So in the preparation reactant will be unknown, right? And the always product will be known. Means if you are preparing the ketone, then product will be 100% the ketone, right? And in the reaction, reactant will be always known, right? If you are going to prepare anything, means you are preparing like a, if there is, so you have to distinguish the reactions. Okay, means there will be only 2 to 3 reactions of the preparation and 2 to 3 reactions of the, means what we have to react with, right? So if we distinguish, then we can easily find one, means we can find reactant or else product, it will be fixed, right? So for 3 reactions reactant will be same, and another 3 reactions product will be same. Then we have to study only the reagents and the, means if we are for the preparation we have to study only product. If it is in reaction, then we can only study the what product, right? So I will easily tell you the tricks of the reagents and some of the reactants and some of the products, so you can easily find out how to write the reactions in the tricky way, right? Whenever there is an exam they have given, you can see the question, you can easily write the reactions. Okay, please watch full video for complete information. Okay, let us start haloalkanes and haloarenes. Okay, first reaction will be Sand-Meyer reaction, right? First reaction will be Sand-Meyer's reaction. What we can say here, here there is a word called Meyer, right? This Meyer indicates me that there is, means Meyer means he is an commander, right? Means commander means a MLA, MP, the person which rule the city, right? Mayor means a person which will rules the city. So if you want the rule, you want the leadership quality, so that I will make a trick called NCC bus. Okay, here we can take the NCC bus, or else you can easily take the NCC. Okay, how it will implement? Okay, let's start. Take a benzene ring, it is in common, right, for all of us. Then we can use the trick here. First we will write this N, right? Then again we will write this C here, right? Okay, now we will make here like this. Okay, then again we will make this C. Okay, then there is a Cu, and then we will make the another one C and L, right? Though, so this is the NCC, right? And again in the presence of HCl we will get the final thing, that will be Cl plus this. Here we will get 2, because always N will be in the 2, means N2 O2, right? Br2 Cl2 H2. So we can easily write here 2 and here plus and minus, right? This will be as a Cl, same, right? So again here we will get N2 as the gas. So N will be here, right? NCC. Okay, if we take the NCC bus, we can easily make that. Here we can make N2Cl, which will be common, means here N will be taken, right? And in the reagent we can take this as the N. Okay, then C, NCC. Okay, here Cu as the NCC, right? For the bus we can take this Br here, right? And then we can take HBr, and there will be reaction will be occur like Br plus N2 gas is released, right? So only by the trick NCC bus we can easily write the Sandmeyer reaction. Okay, okay. Second one will be Finkelstein reaction, right? So here in the Finkelstein reaction, there will be name will be donating, like here there is a F, right? And here there will be I. Okay, this F and I, by this we can write that I will use this I here, right? So by we know that we can use Rx, right, plus NaI. I am using this I here as the NaI. So always remember, in the Finkelstein we will exchange the halogen exchange reaction, we will exchange the this iodine. Okay, so in the iodine only, in the naming only, we will get the Finkelstein reaction, right? And then by this only we will get another reaction like the Schwarz reaction. What? That will be Schwarz reaction. What will be Schwarz reaction indicates? In this Schwarz reaction, same like I, we will take F. Okay, in the Finkelstein reaction we will take second part of the Fickel called I. Okay, in the Finkelstein we will take this I and we will exchange iodine. In this Schwarz we will take this F. Okay, and same reaction, the Rx will be take place, and there will be F, this F. But I will use another trick here called KGF. Instead of K, I will use here AGF, right? If you get a Schwarz reaction or else Finkelstein reaction, you have to remember, yes, Finkelstein, what that will be? Fi. So here I will be used in Finkelstein reaction, F will be used in Schwarz reaction, and this F can be also remember me that KGF, right? In the KGF I will use as AGF. Okay, this AGF is used here, and then there will be exchange of what? RF plus AGX, right? Here I will take the sodium, but here I will take the Ag, means here we will take the silver, right? This silver can be identified by the KGF. Okay. Next we will go for the fourth one, Woods reaction. Right? Woods reaction. Here by the naming only, here we will get the Z. Right? Here we will get the Z. This Z can be write as 2. Right? Here this Z can be write as 2. So we will get same Rx plus same Na but as an 2 2. Right? 2 Rx plus 2 Na in the presence of dry ether. Okay, in every reaction you can use the dry ether here. Then there will be replacement will be take place like R and R plus this halogen will be replaced as NaX. Here also 2, here also 2 and here also 2. Right? So this is the Woods reaction. By the simple of the trick we can identify the Woods reaction. Okay, next reaction it will be fatigue reaction. Right? Fatigue reaction. Here in presence of R we will take phenyl ring. Right? This is phenyl ring. Right? Plus we can take same 2Na in presence of dry ether, we will get same product like the fused phenyl ring, right? Plus we will get 2NaX as the product. Okay, in the Woods reaction also it is same, in the fitting reaction also it is same. Okay, but here there will be R and here there will be phenyl ring. What is different between phenyl and benzene ring? Okay, this is benzene ring and if there is a positive charge here, okay, means the hydrogen is here the hydrogen is removed to get the phenyl. Okay, in presence of plus positive charge we can add the halogen, right? So this is the benzene. Okay, this is the phenyl. These are the difference. Okay, here there will be diphenyl ring is observed and here there will be means phenyl plus aryl halide. This is aryl halide, this is alkyl halide. Okay, okay. Next means we have completed the Sandmeyer reaction by the trick of NCC, right? Then we will use the Finkelstein reaction by the F for the Schwarz, I for the Finkelstein reaction, right? And there is a Schwarz reaction. If we get the Schwarz, we will get the F by the Finkel. If we get the F, we can easily identify KGF. Means this Kg, this K can be replaced by A, then we will get the AGF, which will be AGX, right? So then next will be Woods reaction. This Z indicates me that there is a 2, right? Then we will go for the fitting reaction. Okay, here in the fitting reaction we can take this as the here F, right? This F can be make as P. This F can be make as simply P, means phenyl ring. Okay, this phenyl ring can be make here there is a difference. What is benzene? What is phenyl? Okay, here there will be two phenyl rings and same what we can make in the Woods reaction, same workout will be done in the fitting reaction also. Okay, then next will be Woods fitting reaction. Woods fatigue reaction. What is Woods fatigue reaction? it is same like that only, but here we can take not a 2 mole but 1 mole of phenyl means aryl halide and another mole of alkyl halide. Combination of aryl halide and alkyl halide means woods and fitting. Here it is a woods, this is a fitting. This combination in the presence of dry ether we can get same product like in the presence of he can in the Woods reaction we get R and R, okay, in the Woods reaction, okay, in the fatigue reaction we'll get diphenyl, right, in the fatigue reaction like here we will get this R and phenyl ring as the product plus we will get the this, okay, this here Na plus, right, so we will get the NaX to NaX as the product, okay. You are getting this. This is the Woods reaction. It will be very simple. Next we will come for the haloformed reaction, okay. Next it will be haloform reaction, right. But here in the haloform reaction we can discuss in the aldehyde chapter also and here also, both are we can get the haloform test. I will just give a one note that this haloform test only presents for the in the presence of carbonyl group when there is a C double bond O is attached with CH3. C double bond O group is attached with CH3, then only haloform positive test will be take place, or else only one exception is there, that is for the alcohol, okay. If there is a alcohol then also there will be presence of haloform test means for the ethanol, okay, for the CH3 COH by the this H means here we will get the haloform test because these both are the keto-enol tautomerization, right. This is the keto, this is the enol, so this is the keto-enol, right, so this is the ethanol, right, and this is the carbonyl which is attached to CH3, right, so this is the keto-enol tautomerization. So here for only for these two haloform test will be positive test will be take place. For the MCQs, for the 2 marks, for the 3 marks, this will be asked, okay. There will be 4 options like that for which reaction haloform positive will take place, okay, done, okay. Next we will go for the aldehyde, phenol and ethers, okay. For the in detail chapter explanation I will make the complete video, okay, complete video of alcohols, phenols and ether, okay. Here just I am telling the tricks of this, okay. Now we will go for the alcohols, phenols and ether. Alcohols, phenol and ethers, okay. Here there will be two most important reaction. First one will be alkene give rise to alcohol and the second reaction will be alcohol giving as alkene, okay. In these two reaction one reaction will be 100% fixed, right. So here there will be what hydration is taking place and here there will be dehydration will take place. Okay, the inverse, the reverse of this will be this, and reverse of this will be this. Okay, both are inverse to each other. If you learn one, then another one will be easy. The inverse reaction of one will be another reaction. Okay, here I have one trick, like OLD means old. Here the alcohol, last OL plus this D. Okay, means here alcohol means OL group and last this D will be old, means old as wine, means wine means what? Alcohol means here D indicates me, D remembers me dehydration. In the alcohol we can make dehydration to get the alkene. Okay, so this dehydration we can easily get, right? So by this trick you can understand that where we have to make dehydration and the opposite of that will be hydration. So for alkenes we have to make hydration to get alcohols. For alcohols we have to make dehydration, like OL for the alcohol, D for dehydration, OLD, alcohol dehydration to get the alkenes. Okay, then the another important will be Grignard reagent. Okay, Grignard, by using Grignard reagent. Okay, here also again I will tell that in the previous only I already told us this is the preparation of alcohols. See here, alcohol will be what product, means you can get one product will be confirmed, and this will be the reaction with alcohol, means in the reactant side there will be alcohol is there, right? I already told this, in every reaction if you know the reactant or you can know the product, means you have to learn only reactant and reagent in the what, in the preparation reactions, and you have to learn the reagents and the product in the reaction with, means reaction with alcohols, in those type of reactions. So you have to distinguish between which reactions are these. Okay, okay, now the Grignard reagent can be discussed in aldehyde ketones carboxylic acid chapter. So I will make the distinguish between, means there will be how to make preparation of alcohol, preparation of ketone, preparation of carboxylic acid by using Grignard reagent. Here there will be ketone, here there will be carboxylic acid, and here there will be alcohol. So the three will be discussed in only one reaction, so it can easily help you to distinguish between them and also learn easily. Okay, now we can directly go for the reaction here, which will be Cumin reaction, right? So for the Cumin reaction we can, by the cumin we will prepare the phenol. So by the we can prepare the alcohol, right? So this cumin, this C, in the alphabetical order, where we can get this C, A, B, C, right? 1, 2, 3. So in the third position there will be C. So that in the benzene ring we can have to add the 3 carbon, right? So in benzene ring we have to add 1, 2, 3, 3 carbon, and we have to make the satisfy of the tetravalency. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? So this is the structure of cumin, and then we have to transfer this into that of the what? Alcohol. So here we know the product. This is the phenol, right? This is the alcohol. The overall will be phenol ring, right? So to get the O, what? We have to make addition of oxygen, right? Here we have to add the what? Oxygen here, right? So first of all we have to make the structure of cumin 1 2 3, right? Then H H H H H H H. So this is the structure of cumin, and then we have to add the oxygen. So here oxygen will be O2 form, right? So here only the center one has the only one hydrogen. So here we can add this oxygen, right? So I will write this as OOH. Two oxygen I am adding here, and again I will write this as CH3 and then CH3. These CH3 and this CH3 is added here, and COOH will be written like this. Okay, then by the hydration H3O, right, we can get the what? We can get the phenol plus. Okay, this OH will be right here, and this CH3, right? Means here this C, this both CH3 CH3 and this O can be written like this. So this is the acetone, right? Phenol and acetone. This is the cumin reaction. Okay, by the simple trick like ABC means the third position there is C. We can write the three C's, and we can get the what? Structure of cumin, and then we can easily convert that of the phenol. Okay, then next comes to that of the what? Coal base reaction. Means here only by using the coal base reaction we can learn two reaction at a time. Okay, the coal base reaction and the conversion of salicylic acid to aspirin. These both reaction can be learned in only one trick. Okay, let's start. First we can learn the what? Coal base reaction. Okay, here there is a KOL. In the periodicity we can get the series like the H, right? Hydrogen, lithium, sodium. Then we will get the what? This K, right? Then the uppermost of this K will be Na, which will be a sodium, right? So we can make here this as sodium and this as oval, means alcohol, which will be OH, right? By this we can get the NaOH. Oval means alcohol, right? OH, which will be K. The uppermost of the K will be Na, right? So again I will write this only, right? Again I write the alcohol means a phenol, right? So this is the reaction with alcohol, not the to prepare the alcohol, right? In the cumin we prepared the phenol, right? In the cumin we prepared the phenol, so in the product we will get the phenol. So in the cumin the product will be identified easily because it will be a phenol, and here the which what the reactant will be means phenol, right? Then we can add this NaOH, right? Then we will get this here, the removal of water will take place and we will get ONA here. This will be attached here, okay? And then we will add the CO2 in the heating condition, and then we will add the H plus, okay? Here easily we can get the product, what that will be salicylic acid, okay? We will get the product of salicylic acid, right? Okay. Then this only taken here, like this COOH, then OH, right? Okay. Then plus we can take, we already know that we will know the acetic acid formula. What will be acetic acid? CH3COOOH. Then we will take the 2 mole of acetic acid, okay? Again there will be OH, C double bond O, CH3. Just we have to remove water from this HO. Then we will get the CH3, C double bond O. This O can be written here, and this C double bond O, CH3. So this can be right here, means there will be CH3, C double bond O, C double bond O, CH3, means CH3CO, CH3CO twice, here one, 2 twice, plus 1 will be oxygen, which can be written here, okay? By this we can make the structure of aspirin. How to make that? Only we can write here COOH, okay? Just we have to write this here, okay? This oxygen O, then this CO, then CH3, right? This is the aspirin structure, okay? Then this is the salicylic acid, right? This salicylic acid can be easily converted to that of the aspirin, okay? Using this, here there will be removal of water will be take place, hence this is the anhydrous acetic acid, right? This is anhydrous acetic acid, and here there will be salicylic acid. This will be converted to easily that of the aspirin, okay? Here there will be hydration will taking place, okay? So by this we can easily learn the alcohol's reaction. So here there will be Kolbe's reaction, and this is the one of the reaction which can be salicylic acid is converted into aspirin, okay? Next there will be another reaction called RT reaction, that will be none other than Reimer-Teimer reaction, okay? Which will be RT reaction, right? Okay. So here also we can take the phenol, right? The phenol as reactant. So here also we know that the reactant will be phenol. Then we can take CHCl3 and then NaOH, right? So here the trick will be, there will be one structure, and again we can take here 2 NaOH. So reagents will be NaOH, 1 NaOH, and then 2 NaOH, right? And again here we can take minus NaCl. For the Reimer-Teimer reaction we can take 3 step, 1 NaOH, 2 NaOH, and then minus NaCl. Okay, right? Okay, now here we can just add benzene, and then what we have written here, same reaction. See here, ONA, right? In the cold base reaction, here also we can take ONA, but here this will be add here, means CH, this Cl2 can be written as CH3, Cl3 can be written as Cl2. Okay, and then by the this by the SN2 reaction, you already know that this OH will become here and Cl will be removed out. So 2Cl, I can easily write here that OH, ONA, and then here CH, this Cl2 replaced with OH2, right? Then by the removal of water, we get here aldehyde and then same ONA, right? Now here the minus NaCl and addition of HCl, we get here salicylic, means here aldehyde, salicylic will be taken place. So there will be 3 plus 3 step, NaOH, 2 NaOH minus NaCl. Okay, and same phenol will be take place because as a reactant. Then by this here there will be OH will be converted into ONA, and here the Cl will be replaced by OH here, and then water is removed. Then easily we get the salicylic. Okay, same only in the, okay, next will be Friedel-Crafts alkylation and acylation. Okay, here also similar condition will take place, but this phenol is replaced with that of the anisole. Here anisole is there, which will be 2 mole, plus this CHCl3 is converted into CH3Cl, 2 mole. Here also there is a reagent, same reagent here taken, but as a CHCl3, here CH3Cl. Okay, just there will be replacement will be take place. Okay, then we already know that in the alkylation or in the acylation we'll take anhydride AlCl3 in presence of CS2, we will get the what? We will get the ortho and para, right? 4-methoxytoluene, that will be major, means 4-methoxytoluene will be major and 2-methoxytoluene will be what? It will be minor. Here like this there will be alkylation will take place. Here we will get like this, and here simple, this will be major one, right? So this will be alkylation. In the acylation, here just a CO group will be added in the acylation, that's all. Both alkylation and acylation will be similar. Here there will be alkyl group is added, in the acylation acyl group will be add up. Okay, here for this will be extra. So by this we can complete the alcohol, phenol and ethers, all also the haloalkanes and haloarenes. This is not the complete chapter, but this is the short tricks which we can use in the examination. Okay, and the separate separate chapter will be revised in the upcoming videos. I will make haloalkanes, haloarenes separate video, alcohols, phenols, ether separate video. In that I will discuss ethers like Williamson ether synthesis and some of the important ether synthesis and other reactions also like SN1 reaction, SN2 reaction, some of the MCQs like points. Okay, like that. These are the very much important and some of the tricks having the chapters. Okay, now I will go for the now I will go for aldehyde, ketone and carboxylic acids. Okay, here I have to distinguish some of the reactions. Okay, I will just give an example how to distinguish the reactions. Okay, first will be aldehyde. Here in aldehyde we can distinguish like, see here, first we can take the for the preparation and reaction with. In the preparation of aldehyde, reaction with aldehyde. Okay, or we can taken as ketone also. Okay, here Itard reaction, okay, then Gattermann-Koch reaction, then Rosenmund reduction, then Stephan reduction. Okay, these are the preparation. So here the what product will be aldehyde. Okay, the product will be always aldehyde, so this will be keep in the mind. Then there will be some of the reactions called addition of HCN, addition of HCN to aldehyde or ketone. Okay, and then we will add the Kamenson reduction. Okay, then there will be Wolff-Kishner reduction, right? Then there will be haloform test. Okay, then there will be fillings and Torrent test, right? And then there will be aldol condensation, cross aldol, and then there will be Cannizaro's reaction. So here the reactant will be aldehyde or ketone. Like this you have to distinguish test. Okay, so here we can easily identify the product, easily identify the reactant. So here I will distinguish between what are the preparation reaction, what are the reactions. Okay, reaction with that of the aldehyde and ketone. Okay, now we will start the chapter of the aldehydes. I already discussed some of the reactions of aldehydes. Okay, yet also I will discuss with another time. If you already know that, you can skip these reactions, 2 to 3 reactions. If you again you have to see this, just you can follow here. first will be aldehyde. First will be what? Stephen reduction. Okay, in the Stephen reduction I will take this first letter, last letter, first letter, last letter, that S N R N. Okay, and just I will write these two as in the first R N, then okay, then I will add this to S N, then I will just add the carbon on both sides, C C. Okay, here RCN plus SnCl2. Okay, then I can add HCl, means in the acidic medium it will be optional, you can. Then I will write the R, this R, okay, then this C, and then this N. Okay, in the both side I will add the H and H. Now see here, 1 2 3 1 2, so nitrogen has to want another bond, carbon has to want another bond, so I will write here double bond, 1 2 3 4 1 2 3, done. Okay, this will be that easy, intermediate will be. Then I will make the protonation and I will get the aldehyde as the product, means R C double bond O H. Right, so Stephen reduction, how easy it will be, right? R N R N S N S N, means here I will add carbon carbon, C Cl2 plus in the acidic medium. Okay, and RCN RCN, right? H H, for the valency I will add the double bond here, then protonation I will get aldehyde. That's all, right? Okay, next for the second one. Okay, I will go for the Dibal, D I B A L H. What is the full form of Dibal H? Okay, this will be what? Diisobutyl aluminium hydride. Okay, this is also one of the important, so I am discussed here. D I B A L A L, then H, this will be Dibal H, right? Okay, then there will be Itard reagent. Third one will be Itard reagent. Itard reagent, which will be chromyl chloride. Okay, by taking this, by adding just CS2, we can get the oxidized product of hydrocarbon. So here hydrocarbon, for example you can take toluene like this, hydrocarbon is oxidation to get what? To get aldehydes. Okay, like this type of notes you have to make. Okay, Itard reagent, hydrocarbons is oxidized to get aldehydes. Okay, fourth reaction, which will be Gattermann, M-A-N, Gattermann, then Gattermann Koch, K Gatterman-Koch reaction, right? So here what happened? Here the benzene ring be taken here as a benzene ring. So here the product will be aldehyde. So this is also what? This is also preparation of aldehydes. Okay, so here in the intermediate I will take this CO, okay, bar HCl. Okay, then I will take this anhydrous anhydrous AlCl3. You already know that this anhydrous AlCl3 is used in Friedel-Crafts alkylation also. So this An reminds me anhydrous AlCl3 and this CO reminds me, here you can get that here there will be CO, and then the product will be what? COH will be what? Benzaldehyde, which will be aldehyde. Okay, we will get the aldehyde product. Okay, then we can go further. Next will be Wolff-Kishner reduction. So we can get two reaction here. One will be what? Wolff-Kishner reduction. One will be Wolff-Kishner and another one will be Kemmelson reduction. Another one will be Kemmelson reduction. So we can learn both of them, okay, at a time, so it will be easier for them. So here the reactant will be what? Reactant will be ketone. Here also reactant will be ketone. Right? Then here the product will be what? Hydrocarbon. Here also product will be hydrocarbon, right? But here it will be two-step reaction. It is one-step reaction, right? Since here two scientists Wolff-Kishner are there, so you can take two step. Here there will be only one scientist called Kemmelson. We can take one step. Okay, next we can take that this, since here we will get the Cl. This Cl reminds me this as I, okay, which will be this I will reminds me inorganic reagent. Okay, so here we can take inorganic reagent. This reminds me inorganic reagent, that will be what? That will be zinc amalgam, which will be ZnHg. This reminds me ZnHg. Okay, since here there will be NH is there, so this reminds me, this NH reminds me Wolff-Kishner. Two scientists are there, two step are there, so there will be NH2. So then this will be first step and second step will be KOH, right? So this will be second step, and then there will be removal of water will be take place. From this there will be removal of water will take place. So this is the short note of Wolff-Kishner and that of the emulsion reduction. Okay, so it will be now easier to solve the Wolff-Kushner and emulsion reduction. Okay, okay. Now we can solve the Wolff-Kushner reduction. So here we can take the ketone, then we will add NH2, NH2, and then by this we can remove water. Okay, by this we can remove water, then we will get the as this, and here double bond N, then NH2, this H2 and this O will be removed, right? Removal of water. Okay, then by the KOH bar ethylene glycol. Okay, KOH by ethylene glycol, we get the hydrocarbon. So from this to this, here we get the two step, one step this and another step will be this. Okay, now for the emulsion reduction. Okay, for the emulsion reduction we will take same ketone, but here we will take the what, zinc amalgam. Okay, and then we will get the direct, we will get the direct step, which will be a single step. Okay, these are the difference between Wolff-Kushner and emulsion reduction. So you can learn both simultaneously, so it will be very easier to remember. Okay, next will be what, Torrent reagent. Okay, just for knowledge sake I am telling this, means this is also important for examination, but this is not a reaction. I will just telling the facts here. Tolerance reagent, this is what, this is ammonical AgNO3. in the MCQs, in the fill in the blanks, this question will be asked. Ammonical AgNO3 solution is called as tolerance reagent, and this is only for aldehyde. Okay, and this is not for ketones. Okay, then the Fellings test. Okay, this is not for aromatic aldehyde, not for aromatic aldehydes. Okay, please remember this, so that I am telling this, these are the important points. Just for just for knowledge sake I am telling this. Okay, next we will go for the haloform test. I already told this haloform test, but again I am telling this. Who has not understand, please see here. Who have already knowledge of this, you can just skip this test and see the upcoming tests. Okay, the CH3, the methyl group which is attached to that of the carbonyl, only you test the positive test for the haloform test, or else we can get the what, the CH3 which will be attached to that of the OH. Okay, means the ethanol or the carbonyl attached to CO3 is only give the positive test for the haloform. Remaining other will not give the positive test for the haloform tests. Okay. Now we will go for the aldol condensation. Next will be aldol condensation. Okay, here in the aldol condensation we will learn aldol condensation and that of the Cannizzaro reaction both simultaneously, aldol condensation and Cannizzaro reaction. Okay, here the ALD, this reminds me aldehyde, this oval reminds me alcohol, and this condensation reminds me removal of water. So aldehyde, alcohol and removal of water will be one of the main tricks for the aldol condensation, and then it must have at least what, one alpha hydrogen. Then how to see the alpha hydrogen? What is alpha hydrogen? If the carbonyl group or any functional group has one of the this will be alpha group, right? This alpha group contain a hydrogen. So this alpha group contain the hydrogen, which will be called as alpha hydrogen. Okay, this is the alpha hydrogen. So let's see the what aldol condensation. Okay, here C double bond O, CH3. So here 3 alpha hydrogens are there, and then H plus I can add another aldol. Okay, here C double bond O, CH2, then H. This is also alpha, right? So I will just make that so that this CH2 this, and here the breaking will be means this CH2 will attack here. So 1 2 3 4 5 bond will take place. So this oxygen will, due to more electronegativity of this oxygen, this will take this bond and this oxygen will attack this hydrogen. Okay, like this there will be removal of OH will means removal of means there will be OH minus will take place, the nucleophile will attack, then what will get, this CH2 will attack here, so CH2. Okay, then the again the other group will attack here, means OH, right? Then this will act as CH, means CH3, this CH3, okay, this CH2, and then the H, this will be okay, and this CH2 attack this attachment of this C double bond OH, and H will be there. Okay, here there will be beta hydroxyaldehyde. Okay, means for this it will be alpha and this will be beta. For beta carbon there will be hydroxyl group will be take there, right? See here means this will be beta, this will be alpha, this will be beta. For beta there is hydroxyl group, and then there will be aldehyde. Okay, so beta hydroxyaldehyde. So this is called as what? Beta hydroxyaldehyde, which will be aldol. So from this aldol we have to remove the water. From this we have to remove the what? Water. So aldol condensation you are getting, then it will be aldol condensation. Okay, now we can just remove by what? By heating. Okay, by heating we will just remove here, where we can remove, okay, this O and this H can be removed. Okay, or else this will be OH, this OH and this H can be removed. Okay, then we will get CH2 CH, then double bond CH, C double bond O H. Okay, means here the H will be removed, then that will be given the double bond, and there will be what? Aldol condensation product will be formed. Okay, then what is Cannizzaro reaction? Okay, next will be Cannizzaro's reaction. Here we want at least one alpha hydrogen, but here we don't want what? Alpha hydrogen. Please remember this. Here we don't want alpha hydrogen. Okay, here we don't want alpha hydrogen, just we will take this as, here there is no alpha carbon, then there will be no alpha hydrogen, right? See here, direct hydrogens are attached, then in the presence of what? Concentrated KOH, we will get alcohol plus HCOOK. Okay, this is the Cannizzaro reaction. Okay, then now we will discuss one of the what? Nitration reaction, like that. Okay, here I will discuss here all type of reactions, means nitration, sulfonation. Okay, then chlorination. If we will take the aldehyde here, and then if we add the Cl2, right, in presence of FeCl3, I will get the what? I will get the chlorination, right? So all will take place in the meta position only. Okay, for the Cl2, if I add FeCl3, I will get the metachloroaldehyde, right? Then for the nitration, I will use HNO3 and H2SO4. Okay, then I will get the product as CHO, and here in the meta, because it is electron withdrawing group CHO, right? So here in the meta position, and then for the sulfonation, I will add the fuming H2SO4, means strong H2SO4. I will get the product as sulfonation, which will be CHO, and here SO3H. So this will be what? This will be chlorination. Okay, and this will be nitration, and this will be sulfonation. Like this we can learn three of them in only one reaction. Okay, like this we can learn all in only one reaction. Okay, Next we will go for one of the simplest structures of carboxylic acids. Okay, in the carboxylic acids, some of the in MCQs they can ask the structures. Okay, I will use this as MSG as message. Okay, if you take the message, the short form of message will be MSG, right? That will be malonic acid, succinic acid, and then glutaric acid. Okay, here we will get the only one CH2, 2 CH2 and 3 CH2. Okay, here we will add COOH, COOH, COOH as carboxylic acid. I will add only one CH2. Here I will add 2 CH2. Here I will add 3 CH2. Okay, then I will again write the carboxylic acid means COOH. So if they are for malonic acid, you can add only one CH2. If for succinic acid, you can add 2H2, so 2 CH2. For glutaric acid, you will add 3 CH2. And if they are for oxalic acid, oxalic acid means it will indicate me 0, means it will be COOH and COOH for oxalic acid. Okay, okay, now I will for Grignard reagent. I already told you in the alcohol also I will discuss Grignard reagent in the Grignard reagent. Okay, in the alcohols and ethers. Okay, see here for Grignard reagent. So I will add here for the RMGX as Grignard reagent. Okay, RMGX. Here there will be, you can know that here there will be negative, here it will be positive. So only Grignard reagent will give me S minus R. Minus R means nucleophilic what alkyl group, right? Nucleophilic alkyl group. So here I will add the plus CO2 plus RCN and plus I will add aldehyde. Okay, you can take aldehyde or ketone. I will add here ketone. Okay, R C double bond O R. Now by the using what, dry ether, see here in all cases I am adding here dry ether right? So by the dry ether I will get the same product. This R will attack this carbon, right? See here double bond O, right? And another oxygen, that will be minus and MgX. This MgX will add here. Same here R, this R will attack to this, right? Like this. See here like this. Okay, now this R will attack here this carbon, and again there for this nitrogen MgX, for the heteroatom MgX will add, and this R, and here also R, and here this carbon the R will attach, so that O, here MgX will add, and this there will be R. This R will be attacking here, right? So these are all the intermediates. Then the product will be exciting products like R C double bond O OH, and here there will be R C double bond O R, and here there will be R C R R, and then OH. So here the product will be carboxylic acid. Here the product will be ketone, and here the product will be tertiary alcohol. So in the carboxylic acid chapter we will get this reaction using Grignard reagent. In the aldehyde and ketone we will get this as by using the Grignard reagent, and in the alcohol chapters we will get this as the product using the Grignard reagent. Okay, like this, by using the Grignard reagent we can make the three outcomes, three products. Okay, with the three what, these are the what reactant, these are the product, and the similar reagent, that is Grignard reagent. Okay, then next will be Hell-Vollard-Janoczy reaction. Okay, next will be what, Hell-Vollard-Janoczy reaction. It will be very easy reaction, means I will add some of the notes here, you can just follow this. Here this HELLVOL reminds me the what, halogen, means HALO, this reminds me halo. Okay, and then I will remember the this OL reminds me alcohol. Okay, this will reminds me hell will reminds me halo, this Vollard OL reminds me what, alcohol. So this halogen is attached to that of the alkyl group of carboxylic acid. Okay, so here we can write the what, R alkyl, this alkyl is attached to that of the what, carboxylic acid, right? And this reminds me alcohol here, OH. Okay, alkyl group carboxylic means alkyl group carbonyl alcohol. Okay, you can remember this. Then in the first, the halo means X2 in the presence of red phosphorus, red P. Okay, means here I will remember the Rishabh Pant. Okay, RP, XRP. Okay, XRP. Then I will remember the water here, H2O, and we will get the what here, halogen attached to alkyl group here, X, and then C double bond to OH plus HX. So this is attached to that of the alkyl group, which is attached with C double bond to carbon. Okay, this is the old means Hell-Vollard-Janoczy reaction. And next will be what decarboxylation reaction. Okay, here what we'll get, the important note will be removal of CO2, removal of what, CO2 from sodium salt. Here DCA means DCO means decarboxyl, D means DCO2 from sodium salt. Okay, means here I will write RCOO. So I want to remove this, then I will add sodium. Yes, RCOO Na. Here removal means R, this R, COO, sodium means Na. Okay, removal of CO2 from sodium salt, RCOO. Okay, and here also I will use same trick as NaOH, means here it is common, and I will use CaO, or else you can just add the NaOH and COO. Okay, then you will get the RH plus Na2CO3. How it is possible? Here this will be broken down. NaO means 2 Na2, this O with this C, here we will get the COO, and here again the O, and again these two Na, we will get as Na2CO3 here, and again this R and this H combined we will get RH. Okay, this is the decarboxylation reaction. So this completes the some of the tricks, important reactions of haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones, and carboxylic acids. So in the next upcoming videos I will discuss these reactions or these chapters separately for separate videos, so it will very helpful. So please see those videos also. Thank you and all the best for your exams.